Welcome to Cloud Native Live, where we dive into the code behind Cloud Native. I'm your host today. My name is Whitney Lee. I'm a CNCF ambassador and I'm a developer advocate at VMware Tanzu. So, as you may know, every week we bring new presenters to showcase how to work with cloud native technologies. We will build things, we will break things, and we'll answer your questions. Today, we have Steffi Janis here with us to talk about how to supercharge your infrastructure management with Open Policy Agent. So, just a reminder, this is an official live stream of the CNCF. So, as such, it is subject to the CNCF Code of Conduct. So, that means please don't add anything to the chats that would be in violation of that code of conduct. So, be nice, be respectful of the other folks in the chat, be respectful of Steffi, the presenter, and be respectful to me too, please. I'd appreciate that. Friends who are joining us live, please do say hi in the chat right now. Tell us where you're tuning in from. I love seeing it. I won't be able to shout it out, but I do watch it. And I love to know that people all over the globe are here with us right now. It's so amazing. So as always, if you have questions during the presentation, go ahead and put them in chat. Today, we're not going to answer them right when you have them. We're going to save them for the end, and then we'll do a Q&A part after Steffi's presentation. So with that, I'm going to hand it over to Steffi Janis to kick off today's presentation.
Great. Thank you very much for having me, Whitney. It's amazing to be here again. So I'm Steffi Janis, and I'm the CTO and co-founder of Firefly. And today I'm going to talk about Open Policy Agent, and I'll elaborate and explain why we need this. Before we begin, I'd like to explain a bit about my company, about Firefly. We built the first cloud asset management platform that reduced the cloud complexity using infrastructure as code. And what we do in Firefly is to scan the entire cloud footprint. I mean, hyperscalers like AWS, Azure, Google, etc. We analyze also Kubernetes and SaaS applications. And Firefly analyzes also the infrastructure as code, all IAC tools, from Terraform to CloudFormation, and even Helm charts, etc. We detect the discrepancy, continuously detect the discrepancy between the cloud and the IAC. We can generate Terraform code or IAC code using AI for something that was created manually. We detect drifts and unexpected changes because we are integrated with the cloud events. And we also govern the cloud using Open Policy Agent. And that's why I decided to talk about this subject today. Great. So go ahead, Whitney.
Oh, nothing. I'm just excited.
Great. Cool. So let's begin. And I would like to explain what is OPA and why do we need this. So Open Policy Agent is the first unified policy as code solution with a language called Rego, declarative language called Rego. The idea behind the OPA is that we can we can build any rule that we want and check on a JSON file. I mean, if I have a list of people, and right now I'm building a rule to detect who is more than 30, I can detect from the list of the people exactly, I can get the result. And in this session, I will show you many examples for Kubernetes, for AWS, etc. And generally speaking, you can see Open Policy Agent, that's a mature open source tool, also approved by CNCF. And many companies out there adopted this great open source tool for many other purposes. I told you about Firefly, that we adopted OPA for governing the cloud, for SecOps, DevOps, security, reliability, etc. But out there are solutions for authentication and authorization that utilize OPA for this purpose, or for network firewall rules. For example, we can detect if a network is allowed or denied, etc. So I would like to share my screen and start with a quick example. Thank you, Whitney, for that. Okay. So I brought here an example for a rule, as you can see, that check if we have someone that is older than 20. And now, of course, that I will elaborate and explain exactly how the structure of this rule. And I have two people. I have John Doe and Michael Smith. John Doe, you can see, his age is 30 and hobby is OPA and Kubernetes. And Michael Smith is 18 and his hobbies are serverless. So let's take the OPA rule that I've created here. And I would like to introduce you to the OPA playground. Hold on, and I'm sharing my screen. OPA playground, that's a great way to detect our rule, to analyze, to assess if we build our rule correctly. So I'm taking the OPA Rego rule here. And now let's take the two JSON files, and I would like to show you the result. For John Doe, you can see that it's valid equal to true. And for Michael Smith, you will see the negative, valid equal to false. Great. Let's talk about the structure here. You can see that in Open Policy Agent, I started with a package. Package means what I'm going to run. And then I built here a default variable called valid, that the default value is false. And I override the default value if the age is more than 20. So that's a simple rule for that. And I will show you in this session complicated rules for many purposes. But let's dive more technically. And if somebody here has some questions or would like me to repeat or something like that, feel free to write on the chat. Cool. So first thing, I will run right now the OPA server, and let me zoom in this. You can see that I'm running a Docker run file, Docker run for port 8181. The server is already running, so it won't let me run it again, but it's very easy to run the OPA server. On top of that, we will add our Rego rules because we will add more and more and more policies. And after running the OPA server, after loading the OPA rules, we would like to check JSON files for each rule to understand if a JSON file is complied or not complied. So here, and I will explain what we have here. I'm loading the first OPA rule. You can see that I have a file called example Rego. That's exactly what I showed you on the left side. And I'm running a command to HTTP put to load the data from the example into the Open Policy Agent. Let's run it. Now you can see that it's loaded. And I will check right now John Smith, Michael Smith, and John Doe. So the first one, you can see valid true. You can zoom in, so trust me that that's the result. The second one is a valid false, and we run right now the OPA server on our local machine. And I show you this because it will help me run the second parts of this talk. So just to explain, I'm reading the JSON file of each user, John Doe or Michael Smith, and then I wrap the JSON file with input. And I'm taking this and I'm sending HTTP post for the OPA server, and then I'm forwarding the wrapped JSON, and then I'm getting the result. So that's how it works. Super. Before continuing to the second part of this talk, does anyone have questions?
I have a quick question. So policy seems really powerful. And so if you're trying to start policy into your whole system from scratch, that seems like maybe kind of a dangerous undertaking or something you need to do very delicately. So do you have advice around how to start if you don't have any policy right now, like what you would do as your first like baby steps into getting it working?
Yes, of course. First, we need to understand the data because here I built two users, and in the next phase of this talk, I will show you real examples from AWS or Kubernetes.
Cool.
So we need to understand the data, and then let me show you the Rego playground. So you can see that I always search input.age, input.something.something, because I need to deep dive into the JSON, and this JSON object might be complicated. Here, for example, I have hobbies, list of something, but if I would like to see if I have at least one hobby that contains a pre-requested rule, we need to dive into it. Okay.
Excellent.
Super. Great. So, Whitney, I would like to continue with the second part of this talk, and now I will show you more example, real life example for Kubernetes, for AWS, etc. Let's start with Kubernetes, CNCF. I know that most of the people here love Kubernetes.
Mhm.
So what I did here is to take a Kubernetes deployment. I logged into my kubectl and run kubectl to get the configuration of the specific deployment. You can do it also with the lens, for instance. And as you can see, I have a JSON file, and I will show you this soon, with the deployment itself. Let's copy the JSON here. And I built for you two different rules, one for detecting CPU requests, that all deployments contain the CPU request, mandatory CPU request, and the second one, readiness probe. Because I understand that that's important policy. So let's copy the readiness probe, and let's paste it here, and I'll elaborate on the rule, and let's evaluate. And you'll see here the result. In that case, it's not allowed. And if I need to dive into the rule itself, you can see that I'm using something that was created by the community. I'm importing a library. And if I'm going to this, you'll see under Open Policy Agent, the library itself. And I highly recommend to use pre-created libraries. So we have here the default value, the default variable allow, starting with false, and then I built here a function that detects if I have a readiness probe. As you can see, it runs through the configuration that I have. In that case, if the deployment has spec.template.spec.containers, this sign is really important for you to understand what is that, because I might have a list of containers, and if I would like to check if at least one of the containers inside has readiness probe, so I need to use this sign. And in the end of the day, I run the rule here, and I'm getting the result, and the same also for the CPU request. This one is an easier one, but let's use it. So you can see that I'm also imported a library that was created by the community, and I added here value equal to 1 for default CPU request, and then I deep dive into the configuration, and I built a policy that returns if the deployment has CPU request or not. If I'm running this, I get the result. And one of the pains that we face with is to write the rules. And when you asked me a great question before, and I can tell you that I spent hours for building rules. That's why I highly recommend to utilize AI to generate the rules for you. In the last session that I had here about AAC, the open source tool that we have created at Firefly, I showed some examples for infrastructure as code. What I'm going to show you right now is that you can use AI AAC, AI tool, to generate the policies for you. So what you need to do, you should go to OpenAI and generate an API key. As you can see here under the platform, you can go to the settings, APIs, and generate a new key. And then you need to add the API key into the terminal. It looks like that. Okay.
I'm going to ask you to slow down just a little bit. People, when you were doing the playground earlier, we got the question, will you be sharing the samples? So the examples you gave of OPA before we even got into AI, can we see those examples, or is there a way for them to access, for people to access those later to try them out for themselves?
Yeah, I will upload everything into a dedicated Git, and I will share it with you. Okay.
Okay. So great. And then another question is, can you share the library again.
The library. You mean this one? The AAC?
Maybe so. Will you zoom in on that so people can see what it is, or share the link
By
in the
the way,
private chat and I can
let
put it?
me elaborate, please, because everything that I
Okay.
built here, all the rules and
Uh-huh.
you here, they are available for free for you in Firefly. I mean that the thing
Okay.
that you need to do is to go
Mm-hmm.
to firefly.ai. You can sign up for free, and let me show you all of the rules. Under the policies and insights, we built many rules for you for FinOps, SecOps, reliability, for AWS, Kubernetes, SaaS application, etc. So if right now you would like to see a rule for Kubernetes deployment without CPU request or CPU limit, you can see here the OPA rule, and you can just sign up for free and use our platform. So enjoy from it. Yeah. Whitney, do you have any other question, or I can continue?
Please continue. Some folks are asking to zoom, so you're doing, I think, a pretty good job of being mindful of making sure the font isn't too small.
Yeah.
But just something to watch. Yeah.
Sure. Cool, folks. So what I wanted to show you is AIAC, our first open source tool that actually generates infrastructure as code or policy or whatever you want using AI. So I started with OpenAI that you need to generate the API key for OpenAI, and then I will give you a real example for policy. Let's copy this. AIAC get OPA policy that enforces readiness probe at Kubernetes deployment. And now I will go back to this CLI. It's a bit hard to zoom in, so I'll copy to the text on the top. So I'm running the AIC. Now it's generating this rule with AI. Takes a couple of seconds. And then you will see the rule that was generated by AI. Okay. You can see here the rule itself, and you can use it. Okay, so you can see that this rule was fully generated by AI, and that's the example that I showed you before. So what you can do is to run the CLI command for AIAC, and then you can use an argument for output file. I mean, to save the generated AI policy to a dedicated file, and then you can utilize this. I mean, you can add the policy to the OPA server, and then you can run any configuration that you want to detect the policies. So before continuing, just want to conclude this specific part. I show you some examples for Kubernetes. We took a configuration of deployment, and then we built two rules. Doesn't matter if we build it with AI or we just wrote the policy for you. But in the end of the day, I wanted to check if my Kubernetes deployment complies with those policies. Now I'm going to elaborate on AWS, because here I brought a lot of examples for FinOps, for SecOps, for reliability, etc. So the first thing that we need to do is to scan the cloud. And this is not so easy because, as you know, in AWS specifically, you have more than 20 regions. So you need to walk through all regions and run the CLI command to list your EC2 instances. So what I did here is just as an example, and I will explain how we can actually do an automation for that. So I'm running the EC2 describe instances, and I'll show you the command here. 1 second. EC2 describe instances, minus profile, minus region, and then I'm getting a result. I'm getting list of all my instances. I'm doing the same for volumes and for Lambda function, and I save each of them in a dedicated file, instances or lambdas or whatever it is. Then I built many rules, and I will walk you through them. If we talk about the SecOps, about FinOps, how we can save money, how we can reduce the cloud cost. The first thing that we would like to detect is if we have any stopped instance for more than 6 months. Clearly, we pay for it, and I will show you here an example for that. You can see here on the right side a list of instances. On the left side, I built a rule to detect this. So you can see that I built a function, stopped instances longer than 6 months, that returns the instance ID. Then I'm diving into the configuration. I would like to check if I have any reservation with at least one instance, with at least state.name.stopped. If I have something like that, so clearly the instance is stopped, and you can actually detect it here in the JSON. And then, oops, 1 second, I'm taking a property called state transmission transition reason, and you can see that it's a time. So I parse this time using regex, extract it, and then I built a rule to detect if this number is older than 6 months, and if the answer is yes, I'm extracting the instance ID. So let's click here, let's evaluate the rule, and you will see the instance ID that is open for more than 6 months. The same also for EBS volumes, GPT EBS volumes. You pay for them. It's redundant. You should upgrade them to GP3. So I built here a rule to detect if the volume type is GP2 and the state is in use. And if I'm evaluating the rule, you will see the resource ID, the volume ID that is GP2. By the way, you can find it in Firefly, as I mentioned, for free. And we also give you the recommendation. I mean, the CLI command to upgrade GP2 to GP3, this is really useful. But let's say I would like to show you more examples. Unattached disks, of course, it's something that you pay money for it, so it's redundant. If I have EBS volumes that the attachment length is 0, then clearly I would like to understand which EBS volume is that, and probably I will remove it. More use cases is for Lambda function without concurrent execution limit. I can tell you a real story from Firefly. In a mistake, somebody deployed a Lambda function and it is not configured the execution. Then we paid $4,000 a day, like this. So I highly recommend to detect this as well. And if we dive into the SecOps area, so we can find if we have any EBS volumes, unencrypted disk. You can see here if the disk volume.encryption equal to false. We can run this rule and understand which resources, which volumes do not comply. The same for public EC2 instances. And here I'll give you one more comment for how we can elaborate this rule. I wanted to check which resources, which EC2 instances has public IP. So I will run this rule, and you will see the instance ID. But what happens if right now I would like to elaborate the rule for understanding which EC2 instance has public IP, but the security group is open at least for 22, for SSH. And this is more complicated because it's dependencies between rules. So what we can do is we can build one rule that we will pass all list of all the security groups, and we will ask which security group is open to port 22. Then we'll get a shorter list, and we'll forward the list to the second rule, to this one. And then we can elaborate our rule and not just detect if I have public IP, also we can check if I have any security group that is part of the group of those that are open. And I'll give you an example how you can build something like that. So I built here a rule to detect unsupported Lambda functions. And here you can see a list of Lambda functions like a Python 2.7 or Node.js 0. something, 10 point something. And I built here a rule that runs that walks through the Lambda and check if the runtime is unsupported. And if the answer is yes, I'm returning the function ARM. So exactly like this approach, you can do something more complicated, something more sophisticated, and build a combination of two different rules. Great. You have many other examples here for SecOps. For instance, to detect public accessible assets like EKS with a public API, or S3 bucket that might be public, or S3 bucket without a server-side encryption. Very easy to mitigate, just to configure the KMS key. Or this one of the first controls in CIS benchmark to detect users without MFA. And if we talk about reliability, obviously, one of the most important things is to see tags, to understand that all of our instances or resources generally have a owner tag. So here I am checking that if we have at least one tag that the key has owner, and then I can run the evaluate button and see which instances. And they'll give you more examples for this. If the EC2 instance has public network interfaces, it's also more than one network interface. If the count of this is more than one, it's a bad practice, and we would like to get notification. And I built here, I brought here more examples for auto-scaling group with a single availability zone, or S3 bucket without a versioning, etc. So before continuing, I'm stopping for a moment because I showed you right now Kubernetes and AWS, how you can leverage open policy agent for governing your Kubernetes. You can create policies for FinOps, for SecOps, for reliability, for everything that you want on top of your AWS, and also for your SDLC. And I will walk you very, very briefly through that. But if you want to check that our Git, that we defined that we defined some processes for our Git, we can utilize OPA for this mission to detect to avoid push to master. I mean that only by creating a pull request we'll be able to merge the code, or test coverage. I mean that we can block CI/CD if the test coverage is less than 80%, for example. We can go ahead.
What does the acronym SDLC stand for, please?
Sure, SDLC, Software Development Lifecycle.
Okay, thank you.
Sorry, that's complicated. Thank you for asking. We can also build a rule for the RBAC, role-based access control. I mean, to define the groups and users on top of the Git. And if we talk about the Git configuration itself, we can define the code owner. And today that's mandatory. It's something that you should do to configure who can be the owner, who is the owner, the authorized code reviewer that can touch your, that can approve new pull requests. Or the repository visibility, if it's public or private, and if we have any, this, for example, is mandatory for SOC 2 compliance. You must connect your pull request with Jira. Using the Open Policy Agent, you can do that. And I'd like to hear a question from the audience before I'm continuing to the third part of the talk.
I think I know what your answer is going to be, but the question we have right now is, do you have any example for GCP with FinOps, since you've been showing everything AWS?
Sure.
Yeah.
Sure. It's the same. GCP and AWS, of course, it's two different animals, two different hyperscalers, but you can find, for example, the unattached disk in your virtual machine, VM instance, or you can have a VM instance stopped for more than X month, or you can create a VM instance that is not utilized properly. Exactly, that's something that you can do. And if we talk about BigQuery, we can build a lot of policies regarding that to make sure that we utilize BigQuery correctly. Or if we talk about databases, and let's talk about security, I would like to check if my database is encrypted. So it doesn't matter if it's Azure, Google, or AWS, the whole idea behind is the same. So basically, the rules will be a bit different, but the concept is the same.
Yeah. Where can someone find the community written OPA rules? Because one thing I'm learning from your presentation is the possibility of what you can do with this is just so vast. It's so wildly vast. It's a little overwhelming for someone just hearing about it for the first time in a good way, like all the possibility. It's exciting. The air is electric. But I think a great place to start would be rules that the community has made. Where can we find those?
Yeah, so there are some community, for instance, in Reddit. In Reddit, there is a huge community for OPA. You can see many people over there
Ah.
ask questions. So I actually log in there sometimes. You can find some Git repository, public Git repositories with examples for open policy agent. Depends on your purpose. If you're talking about the cloud and hyperscalers and continuously governance, you can use Firefly to get list of all of those policies.
Excellent.
Great. Shall we continue to the next step?
Sure.
Okay, amazing. Cool, folks. So right now, what I'm going to do is to actually block CI/CD using Open Policy Agent. I brought here Terraform code that I built in the last session of CNCF, and I'll tell you about this. And I will run the Terraform plan command to see which resources are going to be changed. And then I built an OPA rule that detects the resources, the provisioned resources, the resources that are going to be changed. And I'm checking if they have tag owner and tag environment, mandatory tag owner and tag environment. And if we are going to change a resource that does not comply with that, we will block the CI/CD. So before continuing, and I will explain all of this, I'm taking you back to the session that I have made in a CNCF a few weeks ago with you, Whitney, by the way, that we talked about migration from CloudFormation to Terraform. And we used AIC to generate the Terraform code. So here I built Terraform code, fully operated Terraform code, and I will walk you through the code itself. And we also generated a CI/CD. In that case, GitHub pipeline, GitHub Actions. Sorry, this one is the repository. This one is the repository, CNCF webinar, and here under the actions, we will see here that we have a deployment that was generated by AIC. Here, that's the Terraform plan, all the resources that are going to be changed. But in the last session, we talked mostly about security, how I can take this and run security checkers like bridge crew to stop the CI/CD, to block the CI/CD if we have any misconfiguration. So I'm taking the same idea, but instead of focusing specifically on checkoff and security, right now I will show you how we can utilize OPA for that. So let's begin very easily with Terraform init. So give me 1 second, and I will show you the Terraform code. We have here a couple of services. If you will run Terraform apply, it will create web application with some video. Then you have the provider, the latest one in Terraform. You have the variables here, and you have the outputs, TF. Okay. We are in the correct folder. I'm running Terraform init. In order to be able to run the Terraform, we must run the Terraform init, and then we will run the Terraform plan. Takes a few seconds. Here, Terraform successfully initialized. Great. And now let's run the Terraform plan. the for sorry for the typo. Takes a few seconds, and you will see a couple of resources that are going to be added. 25 resources are going to be added, 0 to change, 0 to destroy. So what I've done here is that I wanted to analyze only this and this. I mean, if I have something new, of course, that I would like to block the CI/CD, or if I'm changing an existing resource that does not have the mandatory tags, I will block as well. So let's take the Terraform plan, and I will show you something that you should know. Give me a second, and I will zoom my screen.
So OPA works with a lot of different tools. So you talked about cloud, you talked about Kubernetes, you talked about GitHub, and now this is Terraform. What's the limit? It's like everything?
That's the first unified policies code. Yes, it's everything. Everything policies code. You can use OPA for really for everything.
Right.
Yeah.
Fascinating.
It is, definitely. So I shared here before that I ran the Terraform plan command, and right now I can use the output attribute, and that will save a binary file called tfplan. Okay, if I try to open it, you won't understand nothing because it's a binary data. But that's why I would like to introduce you to a command called Terraform show. Terraform show actually read this binary data and extract it into JSON file that we can do something with that. So if I'm running the command, the Terraform show minus no color and the relevant TF plan, you'll see a huge Terraform, a huge JSON file for the resources that are going to be changed. Then I did beautify here, and I saved the data into an output.json. I mean that right now in this file, I have the provisioning. What is going to be changed if I will apply my code? And I will add it here inside the Rego playground. You can see that it takes 1 second. You can see here that the modules here, the resources changed. If, for example, everything is aligned and I'm just running the plan without changes, this list will be empty, and then my rule will pass. But I've created here an OPA rule, and I will elaborate on that because it's important for me to explain about it. It reads, okay, so first I call the package set.
Zoom in, please. Zoom in, please. Sure. Thank you.
Thank you, Whitney. Thank you very much. Good. So first I created here package CI/CD. Then I took the input and I changed it to tfplan just for being easier for me to understand. I built a generic function for has key, and I'm utilizing this function here to detect if a list of tags contain the key. Then what I'm doing here is to run for each resource change. I mean only provisioned resources. I extract them and I save them in a variable called resources. And now I'm creating a new variable called violations, because for each resource from this list, I would like to check if the resource has the mandatory key, the owner or env. And if I don't have at least if I don't have both of them, so I have here a list of a bunch of resources. Then I'm extracting the address. Address means the location in the Terraform code for those resources. And I'm creating a deny rule with explanation. Here, for instance, it's a medium, and I added the policy description. It's a platform. You can do whatever you want with that. Let's run the rule, and you will see the result. You can see that we have a deny. By the way, some of the resources here comply with they have the mandatory key.
We zoom in. Yeah.
Yeah, I know. Cool.
Oh,
I have a list of violator. As you can see, all of those resources. This is the resource type dot resource name. That's unique in Terraform, and then we can find the list of them that will block the CI/CD. Now I'm going back to the code. After explaining that I am taking the Terraform plan JSON file, I'm running my rule on top of that. And right now, let me share the readme.md here. So I am adding the OPA rule to the OPA server as I showed you in the step 1, step 2 of this talk. Then I'm running the following command. I would like to check to get the result. I would like to get this result, the entire one, as you can see here. So I'm using the OPA server with my Rego rule and getting the result. And I'm extracting the violator. So I'm creating a shell variable called violator that actually runs this one is sending the HTTP request to the OPA server, okay, exactly as I showed you before. And then I'm extracting the result.violator. I mean to extract this. So I will have in my shell list of violators in a variable called violator. Let's run this. Let's echo. We have a list of resources. Then I'm extracting the length. I would like to understand if I have any violator like that. So I also created a variable here in the shell script called length that checked the length of resources. We can see 14 resources. Now I will explain what I did here. If the length is more than 0, then it's not valid, and I'm creating the violators. Else, let's run Terraform apply. So if I'm running this, and I will walk you line by line. So it's the length is 0, and then I'm echo that it's not valid, the violator, else Terraform apply, finish. We will see not valid, and we block the CI/CD. And you can go back to the previous talk that I had here to get the step 4 of the CI/CD using AIC, explaining how you can utilize it. And you can add one more step for OPA, exactly as I showed here right now. And that's my talk for today. If my key takeaways is that you should use OPA. It will help you streamline your DevOps processes. The most painful part of that is to understand which resources you have, and then you can use some open source tool, or you can use Firefly to fetch the resources for you, because we do scan the entire cloud footprint. And if you would like to build your own rules, you can also utilize AI to do it for you.
So did we see very much AI? You showed AI very briefly at the beginning, yes? Or what AI did we see today?
You see an open source tool that we have built, AIC, that is based on the ChatGPT, but we did the prompt engineering over there that you'll be able to get a more accurate result through that. And using that, it generates the OPA rule for you. So you save a lot of time by writing native English.
So are there risks when you're, again, like I associate policy writing with like it's important to keep your system safe, but it's also like so powerful that you need to be careful with it too. So like what checks and balances are there when you're using AI to write your policy to make sure you're not accidentally making it incorrectly so that too much or too little gets through?
Oh, that's a great question. First, don't put any sensitive information, personal information, PII, sensitive data, etc., because you don't want your private keys to be exposed. So always take your Terraform declaration of your prompt and make sure that you remove all of those stuff. And I'll give you an advice. It's a bit more sophisticated while talking about ChatGPT. They have a declaration of something, a definition, sorry, for something called temperature. It's a number between 0 to 1. 0 means no thinking, I mean, no creativity. And while generating code, we should use the temperature 0. If we would like ChatGPT to tell us a story, of course, we need more creativity. So the number would be closer to 1. So yes, I encourage you to use 0 temperature.
That's fascinating. I didn't know about that. I love it. So then what I'd like to hear, I'm interested in the AI part of this. And like what's a real world example of someone using AI to like improve their costs?
Oh, I give you an example from one of our customers. They
Oh.
did
Okay, great.
I'm doing not to promote Firefly, but it's a real use case. Really, really, really
I just walked right into that one.
yeah, amazing. So one of our customers used the AAC, we call it PKI, Policies Code AI, to generate a policy using AI. And using that, it created the rule to detect GP2s for, and also many things related to EC2 instances that are stopped, etc. And
Hmm.
with the generated AI, the customer saved almost $1 million like this because we detected all of the EC2s and all of the GP2 EBS volumes, and they removed all of them.
Cool.
Yeah, so that's why I encourage you to use AI.
That's great. That's it finally all clicked for me. I wasn't quite understanding the AI piece, but the AI is what's going through your existing infrastructure, which is probably vast, and finding all of those instances that you can then write rules about. Is that
Exactly.
correct?
Yeah.
Oh, it all just came together for me. That's super cool. Uh I loved if anyone has any questions, please do ask them. Otherwise, I'm just gonna keep talking. So
Oh,
watch
yeah.
out. um, but one thing so I do this show called Enlightening. You can see my light board behind me, and people come on and they teach me about different tools. And I love also hosting this show because like I did an episode on OPA, so I kind of understand it from a theoretical level, but my show doesn't have any hands-on coding. So then I here I get to see like what it's really like to use it, and I've been enjoying this very much. So anyway, one thing I loved is like seeing how I liked that you explained how rules get chained together and using the output of one as the input for the next one to do more complicated rules. That was really cool. I'm just telling you what I like now. I don't know that there's a question in here. Maybe there is. We'll see. I also really liked like seeing the rules. Like I liked how human readable it was. Like so some of that was you just doing a good job commenting and naming your functions in good ways, but also just in general, Rego was maybe a little more usable than intuitive than what I expected it to be, than what its reputation is. So I thought that was cool.
Yeah, definitely. And of course, that you can use AI to elaborate the prompt. And then, for example, that's exactly what we do in AIC. You can use ChatGPT, but it will give you just the rule itself. So you need to train to give more context. For instance,
Ah,
let's add variables, let's add comments, and let's make it a human readable rule. And using that, you get a OPA rule that looks like you build it.
that's cool. That's awesome. And it's so necessary because I think part of the benefit of policy as code too is like the people who are running the policy maybe didn't write the policy. So when something doesn't pass, it's very important for them to understand why it didn't pass. And it's a learning opportunity too for the people who make future EC2 instances to know or what to like the Kubernetes examples you used at the beginning, that like it has to have a compute limit mentioned and it has to have a readiness probe. So once they go through the experience of having it fail and understanding why it failed, then the next time they try to create a resource, they'll know to put those checks in there. So I like that it's teaching the users a teachable moment.
Yep, and there are many more examples. I just brought two, but there are a bunch of examples specifically for Kubernetes, for the deployments for the horizontal pod autoscalers, HPA, that you should configure one thing and not another, about CADA, if those folks who use CADA, or Prometheus configuration, you can use the CRD of Prometheus, you can configure it properly using Open Policy Agent. Much more. We can talk about Open Policy Agent for hours, and we can
for days, for years, I think. Like that is like a really, it's a thing I learned before in the episode that OPA works with a lot of different tools, but now like today it's like really sinking in like how vast the landscape of like possible OPA. And then well, you tell me, when you chain together different OPA rules, can you be chaining them together between different tools altogether? Yeah.
Yeah, that's a super interesting question, because the OPA rule is specific for the context. I mean, if I have a JSON file and the JSON doesn't look the same, so we need to write two different rules. But there is also a new technology for cloud specific right now called the cross-plane. That's the first, you heard about it, right?
Yeah, I know a lot about cross-plane, yeah.
Yeah. So
but tell me,
for the audience, crossplane is a really interesting open source tool for infrastructure as code, cloud agnostic. Instead of building a few different resources like S3 bucket for AWS, or blob storage for Azure, or GCS for Google, I can build the Kubernetes CRD and for storage, and decide that I'm going to deploy it on AWS. And then I'm building a generic resource, something that will be able to migrate between one cloud to another. And then on top of that, the OPA Rego rule will be almost the same.
Yeah, that's interesting. Crossplane, just like OPA, is can be used in so many ways across so many different technologies that it's like exciting to see all the different things that people come up to do with it. But with crossplane, the way I like to explain crossplane generally is that basically you could take any Kubernetes, any API in the universe, and then you can make it into you can interact with that API via Kubernetes with crossplane. So it brings that API into Kubernetes, and then you can use that control loop. You can integrate it with the rest of your system. It's super cool.
That's correct. I'm looking at this specifically from the cloud perspective, because I'm a cloud guy, so that's why I
and that's, I think, the most popular use case for it right now too, is to use it to provision and manage cloud infrastructure. I have a question here from Akash. Let's see if we can get it on the screen. Oops. Can I use Azure OpenAI?
Azure OpenAI, of course you can do. Yeah, I don't know if you mean for using AIAC, using Azure AI. We added the support for that. And by the way, in Firefly, we also utilize OpenAI in our private instance in VNet. So I highly recommend using Azure OpenAI. I think it's great.
Awesome. Well, I think we're wrapping up today. Is there anything else that you want to say before we say goodbye?
Not something specifically. I have always a sentence for in each target and finish with is that while coding your Terraform code, while coding your infrastructure, always keep your secrets safe. I mean, don't push secrets to the Git. And I will. It's not related specifically to this talk, but I will finish with this sentence.
We should just end every single episode that way. Always, it's just good advice. Yeah, excellent. Well, this has been an absolute pleasure. Thank you for showing us about Open Policy Agent, and specifically how we can use AI to really supercharge how you can enforce policy across your entire cloud estate. That was amazing. Okay, I'm gonna read the ending script now if you feel ready. Okay, I have a script here. Okay, thank you. I would have said thank you anyway, by the way, regardless of whether it was on my script. But anyway, thank you everyone for joining today's episode of Cloud Native Live. Thank you so much, Steffi Janis, teaching us about supercharging your infrastructure management with Open Policy Agent. The chat, y'all were amazing, like always. I loved the questions and the interaction from you. And I love seeing where all y'all are from. I'm from Texas, if you can't tell me putting all the y'alls in there. Here at Cloud Native Live, we bring you the latest cloud native code on Tuesdays and Wednesdays. So thanks for joining us today. And we have another episode tomorrow at the same bat time and same bat channel. And thank you, everyone who watches the recording. And we'll see you again soon. Goodbye, friends.